Hello guys, welcome to our channel. In this video, we are going to see about the short notes for quick revision of chapter Structure of Atom in Chemistry. First, we shall see about the subatomic particles. The name of the subatomic particle is electron. Its discovery is from cathode rays and its charge is minus 1.6 into 10 power minus 19 coulombs and its mass in kilograms is 9.1 into 10 power minus 31 kilograms. For proton, it is discovered from anode rays which has charges plus 1.6 into 10 power minus 19 coulombs and mass is 1.67 into 10 power minus 27 kilograms. Then neutron. It has discovered from alpha particles bombarded on a beryllium thin sheet. It has no charge. It has zero charge and its mass is similar as the proton, which is 1.67 into 10 power minus 27 kilograms. Then atomic models. First model is Thomson model, which is also called plum pudding or watermelon model. Atom. They have taken in this model that atom is spherical in shape, which has positive charge distributed uniformly and negative charge embedded in the sphere. Then Rutherford's nuclear model. It uses alpha particle scattering experiment, in which the experimental setup is likewise. It is the source of alpha particle and this is the lead plate, and here we have the photographic plate and this is the gold foil. This photographic plate, it will give some fluorescent, it has some fluorescent material all over it. It has a covering of a fluorescent material. Whenever the alpha particles hit here, it will give us a reflection of light, so we can conclude that here the alpha particle has embedded here. Then what are the observations Rutherford had taken from the experiment means most of the alpha ray passed through the gold foil undeflected. It does not deflect, it follows its straight line, and a small fraction of alpha particles was deflected by small angles. Some alpha particles only, they have deviated some angle from a very small angle. Then very few alpha particles bounce back, means its deviation is 180 degrees. Then the final model given by the Rutherford is most of the space in the atom is empty. Then the center of atom is occupied by nucleus which have positive charge concentrated. Then nucleus is surrounded by electrons which move around nucleus with a very high speed in circular path called orbits. The electrostatic force of attraction held the nucleus and also electron together, making the atom stable. What is the drawback in Rutherford's model means it cannot explain the stability of atom. Then isotopes. Isotopes means the atomic number will be same and it has different mass number. For example, carbon, different isotopes of carbon, carbon 6 and carbon 12, and carbon 6, carbon 14 are isotopes. Then isobars. Isobars means atomic number is different, mass number is same. For example, carbon has 14 in isobars, nitrogen has 14. So same mass number, atomic number is different, 6 and 7. Then isotones, atoms of which have same number of neutrons. For example, carbon, nitrogen. It is an isotope of carbon which is 13. If you get number of neutrons, how to find number of neutrons means mass number minus atomic number, A minus Z, it is the number of neutrons. So 13 minus 6 is 7 and 14 minus 7 is also 7. So both have same number of neutrons which is 7 here. Then isoelectronic species, atoms which have same number of electrons or isoelectronic. For example, neon and also F minus. Then electromagnetic waves. We know that sound waves require medium for their propagation. But electromagnetic waves do not require any medium. It can move through vacuum. And it moves with the speed of light which is equal to 3 into 10 power 8 meter per second. The wave number, it is represented like this and it is the inverse of wavelength. The experiment which supports wave nature is interference and diffraction. Which supports particle nature means photoelectric effect and black body radiation. Then Planck's quantum law. Atoms and also molecules could emit or absorb energy only in discrete quantities and not in continuous manner known as quantum, and its energy is equal to h nu. Here E is the energy of quantum. We know that light has many energy packets called quanta, and every quanta have equal amount of energy and also have equal amount of frequency. The number of quanta tell about the intensity of the light. If it has more number of quanta or energy packets means the intensity of light is more. If it has less number of quanta means its intensity or brightness is less. Then photoelectric effect. The ejection of electron when certain metals were exposed to the beam of light with threshold frequency is called photoelectric effect. What are the observations in this experiment means there is no time lag between the ejection of electron from the metal surface and the light beam striking. Here the metal surface at which the time it is striking, the photon which is striking, at the same time the electron is releasing from the metal surface and there is no time lag they are saying. The number of electrons ejected is directly proportional to intensity or brightness of the light only and it does not depend upon the frequency of the light. Then third observation is minimum frequency which is required to eject electrons from the metal surface is called threshold frequency. If the light has threshold frequency only it can eject an electron from the metal surface, otherwise it could not. Then Einstein's photoelectric equation is E is equal to h nu, which is the energy of the electromagnetic radiation, which is equal to the stopping potential. Here it is called h nu naught. It is the threshold frequency, and half me v square. What is me? It is the mass of electron. V square means the velocity of the electron, and totally this term is the kinetic energy. This is the Einstein's photoelectric equation. Here based on this equation they are asking many type of questions and most of the questions are asked from this type of formula only. Then atomic spectra. First one is emission spectra. Emission, the spectrum of radiation emitted by a substance that has absorbed energy is called the emission spectrum. What is meant by absorption spectrum is the negative of emission, like a photographic negative of emission spectrum. Here the line spectrum of hydrogen is nu bar equal to 109677 into 1 by n1 square minus 1 by n2 square centimeter inverse. Here this term nu bar is wave number of spectral lines in hydrogen spectrum. It is the wave number and it is also, we know that it is the inverse of wavelength. Then we have different types of series. For first one is Lyman series, second Balmer, Paschen, Brackett, Pfund and Humphrey. What are the n1 values? N1 values means the ground which has the ground state. Lyman has first shell has ground state, Balmer has second shell as its ground state. Like Paschen is 3, Brackett is 4, Pfund 5 and Humphrey is 6. N2 means the next level. After 1, 2, 3 etc. up to infinity. Then 2 means here 3, 4 etc. Likewise we can continue likewise. Then the spectral region. They can ask some theory question from here. Like Lyman series, its spectral region lies in ultraviolet region. Balmer means visible. Other everything lies in infrared region. Then Bohr's model for hydrogen atom. The electron in hydrogen atom can move in circular path of fixed radius and also energy called orbits. The energy of orbit does not change with time. It is stable. It is quantized also. Here electron moves from lower stationary state to higher stationary state when required amount of energy is absorbed by the electron. If it releases means it moves from higher energy state to lower energy state. Means here they are saying electron move from higher energy state to lower energy state means leaving the extra energy in the form of electromagnetic radiation. It emits some electromagnetic radiations they are saying. And angular momentum of the electron is quantized and it does not change with time, which is equal to mvr equal to nh by 2 pi. Here the frequency of radiation absorbed or else emitted is frequency mu equal to delta E divided by h, which is the Planck's constant. Here delta E means E2 minus E1, higher energy level minus lower energy level divided by the Planck's constant. Here each stationary orbit is with definite amount of energy. Each shell have its own energy, which has, if you are going for upper energy, higher state means its energy will be more. Like E1 is less than, E1 is less than E2, which is less than E3 and goes on. Similarly, the difference you see, first difference, the ground state and also the second shell, its energy is maximum and it is decreasing likewise for the differences in their energies. Energy of the electron. Okay, now we are going to see about the different kinds of energy of an electron. The total energy means we all know kinetic energy plus potential energy. Here the energy formula is this one, En. En means the number of shell, in which shell it is present. Likewise, here it is minus 2 pi square z square m e power 4 k square divided by n square h square. Here En is equal to first state of energy into z square divided by n square. It is for hydrogen like atom. Atoms having, which means hydrogen like atoms means which are having only one electron like hydrogen. They are called hydrogen like atom. Then the value of E1 after your if you apply for E1, you will get joule per atom, EV per atom, KCl per mole, and different types of units you can get and different numbers here. The first one is minus 2.18 into 10 power minus 18 into z square by n square in joule per atom. We know 1 electron volt is 1.6 into 10 power minus 19 joules. So if you apply here, you will get this one minus 13.6 into z square divided by n square electron volt per atom. Then we know that calories in joule calorie conversion, 1 calorie equal to 4.12 joules. If you apply here, you will get this one minus 313.6 into 10 power into z square divided by n square kilocalories per mole. And in kilojoules, if you want to write, means kilojoule per mole. Here atom, it is mole. So you will get this number minus 13,312 into z square by n square kilojoule per mole. And also potential energy, total energy. Here E is total energy relationship and also kinetic energy, total energy relationship. Potential energy is 2 times of total energy and kinetic energy is the negative of total energy. Then radius of orbits. Radius is equal to 0.529 into 10 n square divided by z angstrom. And for hydrogen, it is equal to 0.529 into n square in angstrom, because that value for hydrogen is 1. We all know that. Then velocity of electron. Velocity is equal to 2.188 into 10 power 8 into z by n centimeters per second. Here it is given as centimeter. If you apply is for meter, here 10 power 6 will come instead of 10 power 8. The number of revolutions per second or else frequency means this is the formula. Number of revolutions equal to the velocity divided by circumference. What is circumference? Formula means 2 pi r. And its value is 6.6 into 10 power 15 into z square divided by n cube. And Rydberg equation, here we know this one is wave number and it is inverse of wavelength, which is equal to RH. This is the Rydberg constant into z square, which is the atomic number, into 1 by n1 square minus 1 by n2 square. Here the RH value is 109677 into z square into 1 by n1 square minus 1 by n2 square centimeter inverse. If you apply for meter inverse, you should convert this one to centimeter inverse, means it is 10 power minus 2. Here you have to multiply with 10 power plus 2. Then total number of spectral lines. When electron jumps from nth to ground level, nth level to ground level means you should apply this formula, n into n minus 1 by 2. If it jumps from any level means to second level, third level means you should apply this formula. When electron returns from n2 to n1 means n2 minus n1 into n2 minus n1 plus 1 divided by 2. Or else you can apply this one, summation of all n2 minus the ground state n1. And n2 minus n1 is the number of spectral lines in a particular shell. In a particular shell, how much spectral lines it can release. This is the formula. Then dual behavior of matter. De Broglie wavelength, which gives the relationship between the wavelength and also the momentum of the material particle, which is equal to lambda equal to h by mv, or mv means p momentum, h by p. We know that p square by 2m is equal to kinetic energy or some energy. Lambda is, if you apply for p here, lambda becomes h, which is Planck's constant divided by root of 2m into e. We know Planck's constant value is 6.62 into 10 power minus 34 joule second. Heisenberg uncertainty principle means it states that it is impossible to determine the exact position and also the exact momentum or velocity of an electron simultaneously. Means if at a time we can find only the momentum or only the velocity or only the position. At a time we could not find both position or momentum or position or velocity. We can find only one term. Here the formula is delta x into delta px, which is the momentum, greater than or equal to h by 4 pi. Or if you apply for momentum, it will become m into delta v here. Then this principle is not valid for macroscopic object, means Heisenberg principle is not valid for macroscopic object. It is applicable only to microscopic object. Then failure of Bohr model means why does it fail? Means it ignores the dual behavior of matter but also contradicts Heisenberg uncertainty principle, which are required. These things are required, but have ignored all those things, so his model is failed. Then quantum mechanical model of atom. We know quantum number. All quantum numbers for atom we are going to see. Principal quantum number is the first one, which is denoted as n. It determines the size and energy of orbitals, and also the number of allowed orbitals in a shell is equal to n square. You should apply this formula for finding out the number of orbitals in a shell. And azimuthal quantum number is represented by L, and it defines the 3D shape of the orbital. In which shape it is present we can define with the help of the azimuthal quantum number. For given principal quantum number, possible values of azimuthal quantum number is equal to 0, from 0 to n minus 1. The notation of subshells are for S, P, D and F, its value is L value is 0, 1, 2, 3 respectively. Magnetic orbital quantum number, which is represented by ML. It gives us the information about the spatial orientation of orbitals with respect to standard set of coordinate axes. For any subshell, 2L plus 1 values of ML are possible. Here the subshell is SPDF. What are the number of orbitals? Means you apply here 1, 3, 5 and 7. These are all the number of orbitals in that subshell. Then spin quantum number, which is ms, denoted as ms, and it distinguishes the orientation of the 2 electron, which takes the value of positive 1 by 2 and negative 1 by 2. Then filling of orbitals in atom. It is done by certain rules. First one is Aufbau principles. In ground state of atoms, the orbitals are filled in order of their increasing energy. First, the lower energy should be get filled with the electron, and then you should move to higher energy. You should not fill the electrons as in random manner. From lower to higher, you should fill, he is saying, Aufbau principle. Then the maximum number of electrons in a shell, we can find out with this example 2n square, which is n is equal to the which shell, first or second or third, or which shell they are saying. Principal quantum number here is n. Hund's rule of maximum multiplicity. Pairing of electron in degenerate orbitals takes place only after each degenerate orbitals is singly filled. Hund's rule is saying that first an orbital is half filled, and all the orbitals present in a shell should be half filled, then only pairing should take place. At the same level, the same energy having orbitals should be half filled first. If it is done, you should come after that for pairing. He is saying likewise. Then Pauli's exclusion principles means no two electrons in an atom can have the same set of 4 quantum numbers. So quantum numbers, we know that 4 types of quantum numbers, and each electron should have its unique quantum number, he is saying. Then shape of atomic orbitals. It is easy. Shape of s orbital is spherical in shape. Shape of p orbital is dumbbell, and its orientation makes it sense. Here 2px means it align along the x direction. Here it is likewise. This dumbbell is oriented in the x direction. If it's 2py means it is aligned along the y. If it is 2pz means it align along z. Here it is z. Here x. It is y. Then shape of d orbital, it is also double dumbbell. Here it is double dumbbell. dxy means that this one is a plane. It is lying in a plane, and it is dxy means it is lying in xy plane. This is the xy plane here, and it lies likewise perpendicular to the sheet. It is lying likewise. Then dxz means the double dumbbell shaped orbital is lying in xz plane. Here this is the xz plane and it is lying likewise. Then dyz. Dyz means the double shaped orbitals are aligned in yz plane. Here this is the yz plane and it is aligned likewise. Here it is aligned likewise. Then fourth one is dx square minus y square. Here it aligns along the coordinate axis. Here it is not in between two axes, while here it is present in between two coordinate axes in these three examples. But here it aligns along a coordinate axis and it is not in between the coordinate axis. Here if it is x and y means x square minus y square means one dumbbell is aligned along the x direction and also another one is in y direction. X square means one is aligning only in the z direction and it has likewise shape. Then total nodes. How can you find the number of nodes? If they are asking for angular node, radial node means angular node means simply the azimuthal quantum number L. Radial node means n minus L minus 1. And if you want total node means you should add up both of things. Angular node plus radial node and both L will get cancelled out and you will get n minus 1. The energy of orbitals, here it is then likewise. 1s, it has lowest energy. 2s and 2p have similar energy. If it has the same principal quantum number, it is having the same energy and all orbitals are degenerate in nature, which have same energy here, and 3s, 3p, 3d all the three have same energy, which is less than 4s, 4p, 4d, 4f and so on. And it is for hydrogen atom they are saying for. We can apply n plus L rule for finding out. So what does it mean? Means the lower value of the n plus L for an orbital means lower is its energy. It is saying about the energy first. If its value is low, energy is also will be low. If two orbitals have same value of n plus L, if the two orbital it is having same n plus L but it is having different principal quantum number means the orbital with lower value of n value will have lower energy for multi-electron atom. You have to take n as the determining factor which has more energy or which has less energy. So if this case is only applicable if the two orbitals have same value of n plus L, you should go for comparing the n values. Then energy of orbital in same subshell decreases with increase in atomic number. Means you can understand by this example. The orbital which is in same subshell decreases with increase in atomic number means for 2s, for hydrogen atom its Z value is 1. 1 is here Z value is 1. For lithium it is 3. It is 11. And for potassium it is 19. The energy of the orbital in the same subshell 2s, 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 same subshell, it is decreasing with increasing of atomic number. Here atomic number is increasing but the energy gets decreases. So this is the example for this. Then electromagnetic rays. First you should know this order, which is radio waves, microwaves, infrared waves, visible waves, UV rays, X-rays, gamma rays, cosmic rays. Here they will ask you for the frequency, wave number and also wavelength order. First, the frequency and wave number in this direction increases means cosmic rays has the maximum value of frequency or wave number than the radio waves. Wavelength means it decreases in this order. Here cosmic rays have minimum value of wavelength than radio waves, than the other waves also. Then important formula. First is the number of subshell in a principal shell. Means in first shell we are having only S subshell. In second along with S we are having P. Third means SPD. Fourth means SPDF we are having likewise. So the number of subshell in a principal shell means it is equal to N. If it is 1 means it is having only one which is S orbital. 2 means S and P. So we should find likewise. The number of orbitals in a shell means it is equal to n square. The maximum number of electrons in a shell will become 2 into n square. Here the orbitals can hold 2 electrons, so it is 2 times of this one. The number of orbitals in a subshell means 2l plus 1. Then maximum number of electrons in a subshell means it is 2 into 2l plus 1 because orbitals accommodate only 2 electrons. So that is equal to 2 times of this value. So this is the end of our video. If you really like this video, hit the like button, share with your friends and keep watching our channel. If you have any doubts, comment in the comment section. Thanks for watching. Bye. And my notes will be uploaded in the comment section. If you want to have my notes, handwritten notes, you can go and download in the comment section. I will give you the link in the comment section. So thank you. Bye.